There are three different part of this. We're going to talk about Cosmos DB overview. We're going to talk about data structure, and we're going to talk about create and update document by using code. So programmatically, how you can control and manage the Cosmos DB services and all. So in the first section, the Cosmos DB overview, basically what is it, and a lot of people have mindset that Cosmos DB it's a new programming language or new database, and we need to learn different query strings and all that particular thing. So let's get clear those myth and understand what Cosmos DB and what is not. So here, if you see. In today's world, the application must be highly responsive and always online, right? So one of the most obvious challenges when maintaining a relational database system is that most relational engine apply locks and latches to enforce strictly uh, uh, consistency, isolations, durability, all that asset semantics, right? I mean, you can say atomicity. So all that thing they deploy it or they put it on that specific relational databases. This approach basically provides benefit in terms of ensuring a consistent data state within database. However, there are heavy trade-off with respect to concurrency, latency, and availability. So this is something basically more in demand. To achieve low latency and high availability, you must deploy instance of a database engine in a data centers that are close to their users. Database then needed to respond in a real time to significant amount of changes in usage at peak hours, or probably you can say store ever increased volumes of data and make this available to your users in millisecond. So Microsoft Azure Cosmos DB is a database service that is native to Azure, and that focuses on providing a high performance database regardless of your selected API or metadata model. You can deploy Azure Cosmos DB worldwide across all Azure regions, which helps you overcome the previously mentioned challenges, right? I mean, in terms of high availability, low latency, and all that particular thing, and it will help you uh, in terms of maintaining relational database systems and all that problem statement what we have discussed. That will help you to overcome to those problem statements. Partitioning ranges can be dynamically, so you can partition your particular data and then you can programmatically access them. So if you see over here, there are some core features where Cosmos DB supports like a variety of API. So we're going to take a look at it, those API in upcoming slide, but in a nutshell, it offers Cosmos DB is an engine which supports variety of NoSQL data storage APIs on top of it. So as you see, like MongoDB, Cassandra, Table API, etcd, or whatnot, right? So these are some, and they are keep on adding these particular NoSQL APIs on top of it. So you can figure out like what is the business use case you want to achieve and what particular API you wanted to put it on top of it. Core functionality point of view, if I want to consider the Cosmos DB has like four core features that are same regardless of which API you use, right? So that doesn't matter. You go ahead with either MongoDB, or you go ahead with Table API or Cassandra or anything. These features remain same, like global replications, varied consistency levels, or low latency, or probably you can say elastic scale out and all. So these are some particular core features which remain as is if you're gonna work with Cosmos DB and any API you want to use on top of it. Uh, Global replication, this is one of the core feature of Cosmos DB. So here the Azure Cosmos DB has a feature referred to as a turnkey global distribution that automatically replicates the data to other Azure data center across the globe without the need to manually write code or build replication infrastructures and all. It is like built in into the support. So you pick and choose, you select what all the target regions you wanted to replicate. It will start replicating your particular data into global distribution tier. For that you don't have to write any explicit code and all. That is default available with the engine. In terms of consistency level, so basically, so you guys must have heard about different type of consistencies are there, right? So it starts from, if you see the if I highlight just a second, so if you see from starting from strong to go up to eventual, so it starts from left to right, right? So I can say that Azure Cosmos DB provides 5 consistency level: strong, bounded, stateless, session, consistent, prefix, and eventual. So bounded, stateless, session, consistent, prefix, and eventual are referred as relaxed consistency model, because they provide less consistency than strong, which is the most highly consistent model available, right? So if you have a business application where you need data consistency to be more important, that unless and until my replicas, unless and until my copy of the data will not get updated, I don't want the commit operation to be fulfilled, right? So that kind of integrations you can do it. So here you can say that commercially distributed database fall into two categories, right? So database that do not offer well defined or provable consistency choice at all, and database that offer too extreme programmatically sorry programmability and programmability choices, like strong versus eventual consistency. So the former burdens application developers with the specific replication protocols and all, and expects them to make difficult trade-off among consistency. So you need to figure out like what is basically the features you are looking for: consistency, availability, latency, and throughput. uh, you can pick and choose, and then you can have like, okay, I either want to go ahead with extreme strong or extreme eventual. So you can figure out the application. Let's say for example, if I'm working with uploading product images, I mean, I don't need that particular consistency. Once one particular replica is generated, I'm fine with like accessing that data and continue with it. Later on it will perform additional consistency or replica of that particular data. But there are particular methods. Say for example, if I'm working with life science project, or I'm doing some research with DNA kind of activities, and I need to store those particular files into my storage, then you need a kind of strong consistency, right? So you can identify what is the consistency model you are looking for. So the further description of the consistency model is like, I mean, as I said, the 5 consistency. So the consistency level range from very strong consistency, where reads are guaranteed to be visible across replica before a write is fully committed across all replicas, and to eventual consistency, where writes are readable immediately and replicas are eventually consist with the primary. I mean, in a simple language, if I want to consider, like, strong is more I mean, write committed, and once the write operation is completed and visible, then only it will perform the data read write operations. Whereas eventually, if you consider, this level is like loosely consistency model applicable. So in that case, it will not wait for all the replica to be write the data, and it will read it from primary and then continue with the activity. So here basically Cosmos DB supports multiple APIs. So today Azure Cosmos DB can access by using 5 different APIs. The underlying data structure is Azure Cosmos DB is a data model based on a atom record sequence that enabled Azure Cosmos DB to support multiple data models, right? Because of the flexible nature of atom record sequence, Azure Cosmos DB will be able to support many more models and APIs over the time. So right now you see like limited API, but going forward they're gonna come up with some variety of APIs to be supported and all. So it supports like MongoDB API, Table API, Gremlin API. So I would like to say that there was one of the use case where client wanted to migrate the applications from AWS to Azure, and in AWS they were managing a particular application, or even they had 2 different instances. One was running in AWS and one was on premise. So they wanted to manage in a way that their Cosmos DB, MongoDB, they just wanted to make it serverless. So they don't want to get into server management and operational activities and all. And at the same time, they wanted to access the MongoDB without code change or modifying the platform and all. They just wanted to access it into the application. So here basically the role of MongoDB is given to you in a way that you just lift and shift the MongoDB as is into Cosmos DB, and then you just make a call of MongoDB API. That's it. You just need to change your connection string and some those config change, and your application will read as is your particular databases. So this is like one example. So similarly, MongoDB offers, Cosmos DB offers a particular variety of APIs to be supported. So Cassandra, SQL. So if you are willing to build any applications and you are well versed with a specific database type and all, you can pick and choose one of the component, and then you can build your application accordingly. So these are some core 5 APIs right now supported. If you are planning to migrate from NoSQL, so the use case what I just now gave is basically perfectly fitting over here. You can have a particular MongoDB. The example I gave, like, okay, pick and choose a MongoDB, or pick and choose a particular what do you say, this table API or Cassandra or Gremlin. This is one of the simplest way. You can just go ahead with lift and shift, and then probably you can start getting access to your particular database into your existing application. So that is one of the straightforward options available with the help of MongoDB as a service or Cosmos DB as a service on top of it. So you need to identify what is the business use case you are planning to pick it up, and then accordingly you can do all that activities. Here you can see that if I'm planning to migrate my database, right? So Azure Cosmos DB has a MongoDB API and Cassandra API to provide NoSQL service offering for two of the most popular NoSQL database platform. Both APIs are protocol compatible, with the Cassandra API supporting CQL version 4, and probably you can say MongoDB API supporting MongoDB version 5. So many applications can be lifted and shifted to Azure Cosmos DB without the need of code rewrite and all. So as I said, like, this is one of the best way, and it was the solution proposed to the customers, and then they have implemented with it. So that's more about overall usage of Cosmos DB as a service. In the next section, we're gonna talk about like what kind of data structures you're gonna get it in Cosmos DB, and how you can build your application stack further. Okay, so in part 2, Azure Cosmos DB data structures. So let's understand how you can use them and what is the option available. So whenever you create your particular Cosmos DB account, you will get some sort of like resource hierarchy. It starts with like you're gonna have a Cosmos DB account. Inside that you can create a database. Under that you can have your particular collection, which is like your database collection or container. It stores your particular data. So basically it's a group of items programmatically resource, usually related in some way. So basically you can programmatically access them. You can have documents inside that, so that's your particular unit of content. In many cases this will be a JSON document only. You will write your particular store procedures, right? So it will be some sort of application logic written with JavaScript, and you can have the database engine transactions to be performed on top of it. The store procedures, so application, that we have understood. So there is a trigger. So trigger is something like, you can say that if application logic written in JavaScript, right, and you have written some particular additional functions in between, or you wanted to execute that particular script before or after insert, replace, or delete operations and all, you can perform those kind of additional trigger as well. And last but not least, you can get some particular user defined functions also. So though it's a JavaScript, you can write your own custom logic, you can write your your own custom functions, and that way you can handle it. So why I'm explaining this, because when you are planning to create your Cosmos DB, you're gonna have this kind of like hierarchy mostly where you can work. So account database will be on top hierarchy, collection document will be the next level, and then this will fall into the same category. So what is container? So container is, here you can say, so guys, don't get confused. I mean, containers, basically a lot of people get confused like Docker container and all that. So this is the terminology what Microsoft is using. So here you can say that you have a database, and inside that you can have containers. So in Azure Cosmos DB, SQL API database are like essentially containers for collections. Collections are where you place individual documents, and collection is it's kind of automatically grows and shrink as you add or remove your documents inside that, right? So each collection is assigned a throughput value, and that value indicates the maximum throughput for the application and its corresponding document. So for example, if you see over here, it's written RUs. So RU stands for request units. So that's basically your throughput unit. So you can assign the throughput at the database level and share the throughput value among the collections in database. If you have a set of documents that needs throughput beyond the limits and limits of an individual collection, you can distribute the documents among multiple collections. So each collection has its own distinct throughput level and all. So in programming language point of view, or in particular application point of view, you need to figure out what is the throughput unit you are looking for, how many transactions you are planning to read, write and perform those actions on top of it. Based on that, you can plan your particular activities on top of it. Here the most important thing is the database partitioning. So when I'm working with my particular applications, it may be possible that I need to partition my data. So for example, let's say if I'm developing applications for I wanted to do some analysis from my flight, like let's take example of airports and all. So I wanted to do some sort of evaluation that what all the different airports basically traveling with specific flights and all, and what all the passengers, what type of flights are like landing and going through with that. So if I consider that way, then there are plenty of airports are there. How can I get the data of each airport? So probably airport would be my airport data will be my core database, but inside that I can have partitions like airport A, airport B, airport C, or something like that. Or employee directory. Say for example, I wanted to just create a simple example of employee directory where I have a business unit, and that business unit spread across different geography, and I wanted to fetch data from geography wise. So this will help me in terms of accessing that specific data along with it. So here it will give you a kind of options where you can partition your data and you can access them, or you can query them and fetch the data inside your particular application code. So that's the core advantage of partitioning, right? So with the help of row key and that specific combination, you can read the particular data from the partition key and row key. In terms of implementing partition, how you can implement, so for example, if you are developing applications, then you can say you have a logical partition. It's a partition within your physical partition, so that stores all the data associated with a single partition key value, right? So I can say like airport, or probably inside that I can have a specific user ID, and combining both I can access them. So partition ranges can be dynamically subdivided to a seamlessly grow the database as the application grows, while simultaneously managing your high availability. So when container meets the partition prerequisite, partitioning is completely transparent to your application. Azure Cosmos DB basically handles distributing data across physical and logical partitions, and routing query requests to that right partition, so that those kind of activities will be it will be taken care at the back end of the scenarios. So you need to plan what is the role you are planning to get going and how you wanted to access your particular data. So you can programmatically control all that particular activities. Okay, so that's all about the managing Cosmos DB and how you can build and access the Cosmos DB services into your application development. Uh, in next section, we're going to talk about create and update documents by using code. So how you can access programmatically document DB or MongoDB in your using your particular Cosmos DB as a service. In this particular section, part 2, managing the Azure Blob Storage lifecycle. In this particular section, we're gonna take a look at it how you can manage your particular blob storage and its lifecycle. So here I can say that Azure Blob Storage basically offers the different storage service tier, right? So basically these are the pricing plan, I can say, which associated with it, and then the storage consumptions will be applicable, right? So here I can say that storage offers different storage tier, which allows you to store blob storage object data into the most effective manner. The available tier includes premium storage. If you see this left hand side, the green icon, it's an performance tier optimized for mission critical mission critical or high performance applications. This is basically available in a this currently available only for blob storage only, right? So that is something what we can think of. The following three different access tier, this hot, cool and archive, currently available with standard premium tier, standard performance tier, that is in general storage, right? So that is something what we're gonna get it with version 2. So here if I want to consider, the hot storage is optimized for storing data that is accessed frequently. The cold storage is basically optimized for storing data that is infrequently accessed and stored for at least 30 days. And last but not least, the archive storage is optimized to for storing data that's rarely accessed, and it's stored for at least 180 days with with flexible latency requirements, right? So uh, you need to understand like how you wanted to build your particular storage component and what is the options you are looking for. So basically the different storage tier have the different considerations. So I can say that archive storage tier is only available at the blob level and not at the storage account level. Or you can say the data in the cool storage tier can tolerate slightly lower availability, but it still require high availability and similar time to access and throughput characteristic of as hot data. For cool data, a slightly lower availability service agreement is there, SLA is associated with it, and you can say higher access cost compared with hot data are accessible trade-off for lower storage cost and all. You can also consider this way that archive storage is offline and offers the lowest storage cost but also higher cost to access it. You can set only the hot and cool storage tier at the account level. You cannot have both of them to be up and running at the same time. You can't set the archive tier at the account level, right? So at least one of them only you can set it, and you can set the hot, cool and archive tiers at the object level. So I can say that how you wanted to maintain the storage activities, you can plan your particular storage option. So this is majorly applicable from the application development standpoint of view, that I see that my application needs a lot of read write operations. Then in such case, like, this is something what I can look for, or this is the options I should think through. So you can plan your activities on top of it. Once you identify your particular storage point of view, so if I say pricing is left to right, so higher to lower, you can say per GB per month. So the premium blocks, premium storage and the hot access tier have the highest cost per GB per month of data, whereas the cool and archive access tier have the better price rates for large quantities of data. So I can say that if I am looking for long-term archival data and all, then probably I should look for like starting from archive, or probably I can go ahead with some cool data storage which is infrequent access and all. So I can plan my particular storage activities. So now when I say higher and lower, I mean the storage pricings are very, I mean it's like per GB per month it's like 0.002 or something. So it's very low cost commodity storage softwares are available, software driven components are available. So I mean it is one of the like cost optimized storage options are available. Now here if I want to consider the overall life cycle of my particular storage services, then you can consider that in terms of life cycle management point of view. So say for example, database have some data set have some particular unique life cycle. So early in the life cycle people access some data often, but the need for access drops drastically as the data ages, right? So some data stays ideal in the cloud and rarely accessed once stored. Some data expires days or month after creation, while other data set are actively read and modified throughout their lifetimes, right? Azure Blob Storage Lifecycle Management offers a rich rule-based policy for GP version 2. The blob storage accounts, they use the policy to transition your data to the appropriate access tiers, or to expire it at the end of the data lifecycle. So basically you can say that a lifecycle management policy lets you transit your blob to a cooler storage tier, or hot to cool, or hot to archive, or cool to archive, right, to optimize the performance and cost. Delete the blobs at the end of their life cycle, or you can say define the rule to run once per day at storage account level. And basically it applies rules to containers for a subset of blobs by using prefixes as filters. So overall, basically the role of this particular entire life cycle management you can consider is you can say that consider a scenario where you can say a data set frequently accessed during the early stage of the life cycle, but occasionally after 2 weeks beyond the first month the data set is rarely accessed. So in this kind of scenario, hot storage is best during the early stage, cool storage is most appropriate for occasional access, and archival storage is the best tier options for the data ages more than a month. So the purpose of explaining this particular life cycle is to set the time frame or the policy in a way that if my data ages more than xyz particular time frame, then it should move into the specific service tier, right? So while blob is in a, archive access tier, it's considered offline and can't be read or modified. To read data in archive storage, you must first change the tier of the blob, or hot or cool, and this process is basically known as rehydration and can take hours to complete, right? So rehydrating several small blobs concurrently might be additional time to applicable in terms of archive to hot and cool, right? So that is something it might take. So data in blob storage at the premium performance tier doesn't support the hot cool archive access tier. The option for lifecycle management in this particular scenario is set policies to delete the data, right? So after a particular period of time. Alternatively, the data can be copied to another storage account in the standard performance tier and manage using the access data access tier and all. So you need to plan the overall cycle of your particular storage. So for example, the policy which I was talking about, it's look like this. So I can say that a rule could be like life cycle, the type of life cycle I can say, right? So here I can define my particular policies and all. So policy must be include at least one rule, and you can define up to 100 rules in a policy. Okay, rule name can include up to 256 alphanumeric characters, and the name is case sensitive. It must be unique within a policy, and each rule definition is made up of a filter set and action set. So you can say that what activities you wanted to perform, how you wanted to do, which policy to be applicable, what kind of permission metrics you wanted to assign it to your particular storage and all. So multiple activities you can plan, and that will help you in terms of get going with your policy definitions and all. So that's all about like managing blob storage. The third section is basically we're gonna take a look at it working with Azure Blob Storage. So how you can programmatically access your particular blob storage, and what all the development options are available from the code point of view. In section 3, we're gonna talk about create and update documents DB by using code. So in a previous section, the section 1 and section 2, we have talked about the overview of Cosmos DB and the usage of Cosmos DB. Now we're gonna take a look at it how programmatically you can access the Cosmos DB. So here you can to get started with Azure Cosmos DB SQL API, this is like sample example. You all need that Microsoft.azure.cosmos DB package from NuGet, and to reference the appropriate namespace. That's it. Those are the only objective specific to the Cosmos DB you need, and you can start developing your application. So it's not only mandatory that it is only accessible with .NET. If you're working with Java and you have applications, so the example which I gave earlier, that combines the application was developed in Java, that was the e-commerce application, and the database is my MongoDB, which gets integrated and then it will be deployed with along with it. So you can plan that particular solution, and that will help you in terms of setting up the overall solutioning in terms of developing applications and building with this building with the Cosmos DB and all. The further, if you see, like if I continue with the C# code, so how you can access. So here if you see, if you want to connect with your account, so first you will need to add using directives for the namespace for your class, and then you can create a Cosmos client instance by using the endpoint from your Azure Cosmos DB account and one of your key. So this key will be a primary key or secondary key that will give you access to your Cosmos DB, and then probably you can read account asynchronously from the Cosmos DB. So that will help you in terms of retrieving your particular Cosmos client data and all. At the same time, if you are willing to continue with the Cosmos DB, so in that specific scenario, you can manage your programmatically connect with your database programmatically, and at the same time you can also maintain the throughput also. So here if you see, to reference any resource in the SDK, you will need a unique identifier, and here in this example illustrated how to reference an existing database or create a new database in Azure Cosmos DB. So choice is yours, how you wanted to bring your database into picture. Either you just say okay, get database and set the throughput in a portal, or else you create database and then you set the throughput via code as well. Any particular option is fine. At the same time, if you are planning to write some sort of JavaScript with the Cosmos DB, so it's a primary language for creating server-side logic for Azure Cosmos database, and can be used to write probably, let's say, store procedures or user-defined functions or trigger pre-post or something like that. So in this particular scenario, you get that programmatically how you can manage your particular database. All that particular scenarios you can take care of it. So here if you see, like if I want to go ahead with my store procedures to be executed, so if you guys remember, we have talked about that account and all that hierarchy and everything. So one of the component is my particular store procedure. So in a typical database, a transaction can be defined as a sequence of operation, right? So that are performed as a single logical unit of work. Each transaction basically provides atomicity, consistency, isolation, and as well as durability. So that is your acid guarantees, right? So how this particular thing works. So here if you see, like 4 category, like how the acid works over here. If I want to explain, I can say that atomicity guarantees that all work done inside a transaction is treated as a single unit, where either all of it is committed or none is. Consistency make sure that the data is always in a good internal state across transactions. Isolation, so asset from point of view, ACI, isolation guarantees that no two transactions interfere with each other. Generally most commercial system provide a multiple isolation level that can be used as per the application need. And last but not least, the durability. So durability ensures that any change that is committed in the database will always be present. So here I can say that if you see this diagram illustrate that the process running a stored JavaScript procedure on Azure Cosmos DB server, and common task that might run within the store procedures, right? So the scope transactions such as creating, querying, or maybe you can say updating or deleting documents, all that particular process can be taken care with the help of this. So you can identify what kind of like operational activities you want to perform on top of it. So that's more on the store procedure side. Transaction continuation point of view, so here you can say that basically JavaScript functions can return any value, so you can use this value to resume long running functions that after the server specifies time is over. For example, you might have a functionality to upload millions of documents, right? If the server specific time is over before all documents upload, you can run a pointer to indicate how far your function progress in a document upload. So this will make it easier to resume processing in a new function iteration, and that will help you to get going in terms of performing those transaction activities and all. So how you can do that? So here in the diagram, if you see the concurrency, like what is the way you to manage that particular thing and all. So I can say that the e tag value is generated on the server every time when you update the documents, right? So that basically if the e tag value stay constant, it means that no other process has updated to the document. However, if the e tag value unexpectedly mutate or change, that means that another concurrent process has updated the document. So based on that, it will pick up that specific task and continue with the concurrency activities the way you want it. So in a nutshell, basically Cosmos DB provide or offer all the variety of operations which you are looking for your NoSQL database operations to be performed, and you can bring all your popular data structures, all your like 5 popular data structures in Cosmos DB as a service, and you can build choice of your particular applications the way you want it. So we're gonna take a look at it, the lab over here, so constructing a polyglot data solution. So this will help you in terms of get going with how you can build your overall solution with the help of Cosmos DB as a service. So far we have gone through with part 1 and part 2, and we have discussed about various different operations of blob storage. In part 3, we're going to talk about how we can work with Azure Blob Storage and what are the options available in terms of working with storage services, right? So let's get started. So in this managing blob operations and metadata, so this is something core component. So basically when you are developing any applications, you need to read the blob metadata, when it is created, what is the timestamp, and variety of properties are part of it, right? So we can at least get to know like how we can create and what are the options available. So I can consider over here that the blob containers and blob support like custom metadata. It represents basically it represented as HTTP headers, and metadata headers can be set on the request that creates a new container or blob resource. So on a request that explicitly creates a property on existing resources, uh, I can say that majorly the metadata on a blob container resource can be retrieve, or you can say retrieve or set directly without returning or altering the content of the resource. I mean the major use case is If you need some particular informations to be retrieved with the help of specific blob storage, then that will help you to perform some relative operations on top of it, right? So during the creation of the new resource or during the special operation that explicitly you want to execute on top of it, majorly the managing I mean via programming methodology, you can maintain or manage your particular blob properties and metadata. So here these are some particular sample, you can say, a blob container properties, right? So for example, containers and blob also supports like certain standard HTTP properties. So they are probably, you see, e tag, last modified, public access, hash immutability policies, or has legal hold or anything. So these are some particular standard container properties that will help you in terms of working with your particular blob storage. So here if you see, I mean, development point of view, so in our example, in our particular application code, we're going to take a look at it like, okay, if I want to build any application, and if I want to customize or I want to modify any particular activity, what is the way to do it? How can I execute that particular thing? What is the way I can read my data programmatically? If I want to check whether that particular blob has any cross domain access or not, or those kind of features, we can take a look at it, and that will help you in terms of programmatically accessing or retrieving your particular blob storage and all. Uh, if I wanted to consider in terms of coding point of view, so the blob storage basically supports all the programming libraries. Basically, if you are working with .NET, Java, PHP, Python, or any programming language background you're gonna have, you can retrieve these particular code. So right now, if you see the sample code, basically it highlights the straightforward C# code. So in this particular code, here the if I want to highlight, just a second, sorry. So if you want to consider, like here we have a particular cloud storage account, right? So that is something, a kind of you can say, cloud storage account contains the create blob cloud account, right? So here it's, if you see, this is particular method which give you a programmatically access to a client that manage your file shares, right? You also have to reference your specific blob container. You can use get container reference. So if you see, like, this is my particular specific container reference. For example, I wanted to access about image, so this is like a specific container reference. I can get it via this specific method of the cloud blob. I mean, this is my particular class, cloud blob client. This is my particular class, and under that I'll be taking a specific reference of my particular container, and that is I'm storing inside my particular cloud blob container. So here what we are doing, like with a hydrated reference, you can perform actions such as fetching the properties or metadata, to be more precise, of the containers, right? So here we are capturing a value of those container reference into this cloud blob container. So that helps me to fetch the all attribute in asynchronous manner from that specific container. And what we are referring over here, that there are some particular predefined methods which go and checks that, okay, whether this container exists in particular in my particular storage account or not. If not, then it will create it. So it's, this is like kind of a singleton pattern where it goes and check that whether object exists or not. If not, then go ahead and create it, and then we are just like simply fetching the attribute async, right? So these are some particular standard methodology applicable from the storage point of view, and this is something same applicable either you work with Java, .NET, PHP, or any programming language. The class library, the class name, the methodology in terms of accessing your particular blob storage and container related data informations and all, it will remain as is. So if you see over here, the additional component. So for example, if I say that using this existing cloud blob container variable, we have the name as in container given, you can set and retrieve custom metadata for the container instance. So this metadata is hydrated when you call the fetch attribute. So here if you see right now, I'm just trying to, in previous slide we have seen that fetch attribute was there, right? So or fetch attribute async method on your blob container to populate the metadata collections. So here the metadata collection, so the following code what you see, this container.metadata.add or container.metadata category. So these are some particular information. So in this example, like collection add method, right? So that will help you in terms of getting those particular details inside. So this is like a kind of to be more precise, like await dot container dot set metadata async, this method persists to newly set metadata. You must call this particular method of the cloud blob container class. So this will help you in terms of implicitly accessing this particular metadata information of this particular blob storage. So why I'm explaining all this, because the reason behind that is when you are planning to build any applications and you wanted to retrieve these blobs. So for example, let's say you are working with some insurance company, and now you just wanted to take care of the documents uploaded, the history of that documents, or probably you're working in a specific let's say banking sectors, or probably you're working with some e-commerce company, and now you just wanted to collect all the blob data to be uploaded into the system, and you wanted to keep a track of those particular storage data and all. So the role of this metadata is to give you some insight about your storage and provide you particular details from your particular metadatas, right? So that is something you can use it programmatically in your code. Now when we are working from the programmatically point of view, there is one more core concept arrive, like when you are retrieving the blob, when you are reading the blob, how you can make sure that somebody else is not modifying that blob. Because currently let's assume that you are trying to modify or read the property of that blob, and at the same time somebody else is like modifying that particular blob. So whatever the data you are trying to retrieve will not be applicable, right? So there is a concept of blob lease. Okay, so lease is something you can say that it's a kind of, I mean, by name you can make it out that it's a lease operation. You will get some sort of access to your particular blob, and that will help that okay, I mean, blob operation, if you are performing some blob operation like reading and writing some data on top of it, the other candidate who or other programming thread who are trying to access that blob, they will get the read only operations, right? So if you see this particular component, so the role of this lease blob is that it's a kind of operational activity which establish and manage a lock on your particular blob for write and delete operation, and the lock duration can be 15 to 60 seconds, or it can be infinite, right? Depend on your programming or depend on your business requirement. There is no other thread gonna read or write or anything. You just keep like infinite access of your particular blob. So in this, after lock established on a blob, the owner of the lock has exclusive access to write or update the blob during the duration of this, and all subsequent clients must wait to perform any updates on the blob until the owner of the lock blob completes the operation. So that's something you need to like define. So whenever there are some particular lease blob operations are there, so if you see like list of blob operations, minimum 15 to 60 seconds operations you can perform on top of it. Of course, I mean, you have a choice. If you want to set a specific time, you can do so. So there are some standard operations available like acquire, renew, change, release, break. These are some particular around 4 or 5 modes which you can use it in terms of performing some operations on top of the blob. Acquire is like, I mean, you can say you request a new lease, probably let's say change. So you want to change the ID of an existing lease, or maybe let's say release. So this is something to free the lease if no longer needed, so that another client may immediately acquire a lease against the blob. So these are some particular standard lease operations that is something probably make you active in terms of working with the blob operations, and you can acquire the lease and probably you can work programmatically. This is something a kind of you can say a standard programming methodology or the operational activity which you can perform on top of the blob storage. So that's all.